the title "Maximising Value from Measurement." I didn't realise how much I was going to trip over. It's not the easiest one to say, but anyway, hello and welcome. So first of all, let me minimise this. Just a quick introduction. So what's a few things I'm going to be going through tonight. So some advances in survey technology that we've had over the past few years, the range of data that we can collect using this new tech, maximising the value from it, and then how we can go about collaboration with that data and sharing some of that data. And as we go through, I'll also be trying to highlight some of the benefits of this, but also some of the pitfalls that you might want to watch out for. So let's try and move the slides on. Okay, good. Yep. Okay. Right. So there are lots of great survey tech out there, so I can't cover all of it tonight. So these are the ones that I've picked. So we've got some track-mounted systems to go through, drones or UAVs, 3D laser scanning, SLAM technology, of which more later, and 360 imagery. But first of all, for the few of you that in the room and online that don't know me at all, how did I get here? I've been asking myself this question. I blame Mike. So my dad actually worked on the railway. So when I was very, very little, I wanted to be a train driver because that was the only thing I knew on the railway. But I actually went off and did a degree in archaeology, so slightly left field. Through that, I got an interest in surveying, so picked up the sort of surveying bug through archaeology, and then migrated onto the railway instead. So I started on the railway in 2008, which apparently is quite a long time ago now, and joined TfL in 2014. So just before I joined TfL, I went back to uni and did sort of a postgraduate study in geodesy and engineering surveying, and then joined TfL in 2014, approximately. I also thought I'd get a little plug in here. So I did the PWI Track Engineering Diploma in 2018, and very good it was too. I recommend it to anybody. And so for the past year or so, I've been the principal engineering leader in the land survey team within TfL. So that's how I got here. I struggled to find any pictures, so that's me at Camden, one of the very few that I could find me actually doing some work. So before we crack into exactly like these different types of surveying equipment and tech that we can use, really the starting point has got to be the questions that we ask at the start. So it's not, I want a drone survey. It's well, why are we doing this survey at all? Why are we doing it? What is it that we're trying to measure? Because that's really going to inform what sort of method we choose to use. And what is this data for? What are we going to use it for? Are we trying to do like a track design? Are we trying to do just feasibility study at the moment? What sort of budget have we got? And so that feeds into some of the constraints that we might have when we're thinking about what to use. I put access there because it is one of our constraints. On the railway, it's probably one of our biggest constraints. So that is definitely something we want to think about. Our access sort of windows, our access timescales, all those sorts of things. Network rails is even more difficult than London Underground. So, right. And then, yeah, we want to choose the tech to meet the spec. So depending if, for example, we're trying to do a survey for a new track design, then the accuracies we're working to and the tolerances that we've got to install that design are going to be really tight. Whereas if we're, maybe it's a station building and we just want to know what area that we've got, because we want to put some shops in, so we're maximising the value from the retail space that we've got. We want to know how much space it is. That's going to be a much lower accuracy that we'll need to get an idea for that. Things we might want to reference to understand these accuracies that we're working to. So obviously the standards. So we've got network rail standards, we've got the LU standards, and generally for these we've got bands within those for the type of survey or type that we might want to do. So we can consult those to find that information. the end user who is using this data. If it's a designer and they're using CAD, then fine, we might be creating a CAD model. If it's someone's trying to use an Excel spreadsheet to do some calculations, then giving them a CAD model probably isn't going to help them very much. So I have to think about that. And then this future value, so going back to this maximising the value from stuff, what future value might it have? If we can collect a little bit more now and it won't take much more time and it won't cost much more money, then do we collect that so we've got it and we can reuse it for some other things in the future? Maybe a different team can use it for something else. So that's certainly something that we want to consider. So I thought I had to put this bit in because this is what a lot of our survey measurements is going to be based on. So if we're going for that high accuracy, high precision sort of surveys, which is probably sort of more the end that I'm going to talk about, then we want to know which grid systems, which data we're basing all of this survey data on. It's got to be related to something. And I guess the most important thing from this is you want to use the right grid for what it is you're trying to survey. So if you go to Euston, you could be using the London survey grid. So the hello, you could be using the London survey grid to survey the tunnels at Euston, but equally HS2 is coming in to London into Euston, well, hopefully. Anyway, but you want to be on the HS2 grid if you're trying to do a survey related to that. Potentially, you can overlay these surveys if you do a translation between them, but you're never going to get it 100% perfect. There's going to be some distortion. So yeah, these are the two main sort of things I'm going to talk about. So the London survey grid is what we use within London Underground, and it covers the whole of the London area, and it's effectively a scale factor of 1, which means if we're surveying, so if we measure 100 meters on the ground, it's 100 meters on the grid. If you try and go out to something like the Ordnance Survey, we have to distort. So I'm hoping that, so when I say that the world is roughly a globe, a sphere, I hope no one in here thinks otherwise. Right. But when we flatten that out to be able to work, do our designs, we necessarily get some distortion when we do that. Luckily, London is small enough that our grid can work with this 1-to-1 scale. And then for things like HS2, we have something called a snake grid, which is a pretty cool name, but effectively means over a long corridor that you get with a railway line, we can minimize that distortion and make it as close as possible to 1, so that when we're measuring stuff on the ground, we don't have to start applying different scale factors along the route and changing things as we go. We've got one set of survey control, which brings me on to this bit, survey control. You may have seen points like this out in the world, maybe on track, but could be anywhere else. So these are, I guess the key thing with this is that these are physical points that are out there in the environment across our project. So we need to install these, and they will form a network of reference points that we will give coordinates that will be on our grid system. And then this is what we're going to use as our basis for all of our survey measurements, and then potentially our setting out a little bit later down the line. So I'm going to keep referring back to these bits probably because the key bit through like the life cycle of a project is that this survey control is what we're going to keep referring back to. So it's important that we get it right to start with when we start our project, and it's important that they remain, or at least enough of them remain, through the life cycle of that project, and we don't destroy them as we go, that we keep a record of them, that if we want to maintain whatever it is afterwards, to the design position, say, so if it's a track position, that again we maintain these, we don't destroy them, we may need to actively maintain them as well. So there's a few just different types on here of, there's nails, the black and white target is for scanning, which we'll come on to a bit later, and the red one is a prism, also important. important. Oh, now, in fact. So cracking on with the actual tech, the track mounted systems, these are modular systems. So they've actually been around for quite a long time, but they keep getting incrementally better and useful in different ways. So, which to be honest is the case for quite a lot of survey equipment. So things like the total stations, which is that sort of top right one. So the total station is going to be used to help us install that control network that we're going to need at the start. So between our control points, we're measuring distances and angles to get that network set to start with. And then, these have come on from, back in the day, it was theodolites, and it was the angles we're measuring, and we had to measure distances with a chain. We've now got electronic distance measurers, but we also have, so the newest kit has got AI built into it, so it can recognize different types of prism. It can work in lots of different conditions. So whether that is miserly rain that gets through everything, whether it is, it also works with, there are total stations that have scanners in them as well, so you can do sort of one-stop shop. It does mean that maybe it's not doing each of those things to the highest ability because it's doing everything, but it gives you some good options. So the total stations, the this track mounted system, so the one that you can see on the left, is the basis of it. So the bottom part is essentially doing cant and gauge measurements. So it's got a tilt sensor within it that's going to measure your cant. It's got a gauge arm that's going to be measuring the gauge, and then it's got that laptop attached to it to record the data. And the bit that sticks up the middle is the bit we can sort of interchange with stuff. So we can put a prism onto that, and we can push that trolley. I'm going to call it a trolley rather than track mounted system. We can push that trolley along the track, and using the total station, we can take measurements to that as we go along and record the track geometry to within a few millimeters. So that's a really good high accuracy way of working. Or we can add things like this. So the things on that one is a scanner, and that will basically set it perpendicular to the track and spinning around as a scanner and collecting millions of points a second as we push it along the track. And then we've got essentially the whole structure is recorded relative to that track position. So we can measure absolute position. We can just measure the relative geometry, so the changes in gauge and curvature with the trolley as we push it along, depending on what information it is that we want out. If we're just pushing the trolley along continuously, you can push it at walking pace, and you can get quite a lot done in a shift. You can go miles. If you're trying to do it at that high accuracy, surveying the track position, it's going to be a little bit slower, but it depends what you want. And you can also use it to do the setting out when you get to that point as well, if you upload the design onto it. So what's next? Oh, a very smiley map. So other bits that we can add onto this, I say it's modular. On the bottom of that picture, you can see there's a sort of small silver box that we've added onto the trolley there, and that is an inertial measurement system, or measurement unit, sorry, I should say. So inside that wee box, we've got accelerometers and gyroscopes, and they essentially track the change in position, velocity, and orientation as we move along the track. So again, we can just keep pushing. We're going at walking pace, and we're collecting loads and loads of data. So if we combine that with survey control, we can get pretty close to what we would with the stopping and going survey. Not quite yet. Talk to the manufacturers, they would say it's just as good. I don't know if it's because LU has got quite exciting geometry. We have these, reverse curves. We have tight radius curves, and maybe that's not the best for this technology. So we can install more control points along the route. The more that we collect, especially if we put them in maybe close to the reversing point, things like that of a reverse curve, then we can get it very, very close to the stop and go method. And so it's much faster. So it depends what you want it for. And then again, so this is something that we've acquired this year in the TFL. We can add GNSS, or also known as GPS, onto this system as well. So this one, all singing, all dancing. We've got the trolley base there for the Canton gauge. We've got the IMU there, which has changed colour now yellow and grey. We've got the scanner on there as well, and now we've got a pole at the side with the GPS receiver on the top of it. It's getting quite heavy, this bit of kit now. I haven't tried picking it up, but yes. So another of the improvements that we've got is there is now a new scanner for this, which is smaller, lighter, faster, and can do things in colour. So again, there's incremental improvements. So once we get one of those, it'll make it a little bit lighter again. Downside, well, some of the downsides of this. So we've got a lower absolute positional accuracy with this. So GPS is good, but it's not as good as having a survey control network. It ballpark sort of 20 mil in plan, a little bit worse in the vertical. But it doesn't mean we don't need any survey control out there. We can go out there, put this on, switch on the receiver, and start pushing, and we can collect that data. One thing we do need is a view of the sky, because GPS doesn't work in a tunnel. Much as we tried, no. And see on LU, we have tunnels. We have quite a lot of tunnels, but 50% of our network is actually outside. So this is still useful. It's just not useful everywhere, but still good. The multiple constellations that I've put up there is because we have, so GPS is the American system, that's the first one, but there's also a Russian constellation, GLONASS, there's a European one, there's a Chinese one, and we can collect data from all of those, and so it's getting better and better. So whereas GPS, sort of 20 years ago, one would have been a lot more involved, but also wouldn't have got you anywhere near, we're now getting down to those sort of millimeter kind of tens of millimeter accuracy rather than sort of a meter. And the dual frequency is the different signals that come from the satellite. So whereas again previously high buildings, of which London, can be problematic for the GPS because essentially the signals bounce off the buildings and confuse it as to where it is. The dual frequency means we've got different signals, and so it can sort of essentially cancel out and get you again a better position. So there's that one. Lovely bit of tech. Have I gone the wrong way? No. So just to recap then of what we can get. So we can get the track geometry from this kind of data. We can get scan data. So essentially a point cloud of data, which one of the major things with that is the gauging and clearance analysis and assessments that we need to do. Again, particularly LU, very tight on that. And we can extract things like platform edges for the stepping analysis as well. We can extract track and trackside features out of this scan data. So rather than going along and with a total station and collecting just the bits that we need or think we need, if we're scanning it and collecting all that data, we can extract out of that instead. And we can even extract the rails. So we have recently done a survey along the Metropolitan line. We have the Chiltern lines, the Network Rail Chiltern lines running alongside. Now, we can go out in engineering hours onto the Metropolitan line fairly straightforward. We can push the trolley along. If we then want the data for the Network Rail line to get the passing clearance between those two lines, we've got possessions, we've got costs, we've got nightmare. But we can extract those rails from the scan data that we've collected from the Metropolitan line. So actually we don't need to go and get that access to actually get boots on the ground on Network Rail. We can just extract it from the scan data. So that's quite handy. Moving on to gauging. So this is just trying to illustrate something what the scanner on the trolley is doing. So it's perpendicular to the trolley, and as we push it along, so the scanner is just whirring around, collecting millions of points per second, and we end up with this sort of continuous helix going down the track, so yeah, captures all of the trackside features, everything that is within its line of sight, shall we say. So you can end up with some shadows if you're above the platform edge and it's scanning downwards. That section underneath the platform edge, you're going to have a little shadow there, so it can only see what it can see from that scanner head position. There are trolley systems that have two scanners in a butterfly kind of formation, so that they're looking slightly ahead and slightly behind. So you can get rid of some of the shadows from that methodology. So that is an option as well. And then from that data, essentially we chop it up. So we can to put it into the gauging software. So at the moment, certainly for LU, we're still using ClearRoute and bringing in the dgauge RIF software as well for gauging. But both of those softwares take essentially dumbed down data, I'm going to say. So an SC0 file is the format. I'm going to move this up rather than trying to explain it. I'm going to show you a picture. That's much easier. So we take maybe say 5 meters, we cut it up into 5 meter sections, that scan data, and we compress it so that we end up with one profile. So on the left, that's the profile that we've created, because this is what our gauging software can cope with from the point of view of doing the assessment. It does make it a bit tricky maybe to know what some of these infringements might be. So there on the side, we've got this 35mm infringement. And if we go out on site, which as we may have had to do, go outside and go, well, what is that? It's causing this problem. What is it? Oh, it's these boxes. Okay, cool. But we've actually got all this scan data. We could just look in the scan data. So if we look at the scan data, we can see that actually it's these 2 boxes here, and then we can sort of see how much it might be infringing by. So in terms of the visualization of what your problems could be out on site, it's a lot more useful. And then, yeah, this part is the, so we have to Trimble software, it's called GDO, and we can actually upload all this scan data into there and then push these structure profiles through the scan data, and it will highlight up in red the bits that are clashing. So we've got a bit of render there and platform edge, which will always be clashing to the structure profile. The bit that I'm waiting for, which I'd love to be able to go, yes, and the advancement is that we can just do all of this stuff in the point cloud and it's all approved. It's not yet, but that's the bit that I'm hoping that we get to. I can't imagine how much computing power that's going to need, though. I think it's going to be quite a lot. The scan data, say there's millions of points. So the scanner data, the point cloud itself is huge. And then all of that analysis that it's got to do is a lot as well. So this works well for visualization. This is quite a simple assessment that it's doing. It hasn't got all the parameters that would be included in sort of a ClearRoute assessment that you'd need to like prove your design or whatever. Okay, so it's a bit of a case study on the Bakerloo line upgrade to show how we've used some of this, put some of this tech to use recently. So the sort of background of this slide, you can see the control network that we had to install. Well, no, a little bit of the control network that we had to install for the Bakerloo line. So it comprises 22 kilometres of tunnel section. It goes out beyond that, but the tunnel section is 22k. The survey control network is 1,200, well, more than 1,200 control points that needed to be installed and then measured and calculated. So that took a good couple of months, maybe a few months. Took a wee while. But then we used that IMS, that inertial measurement system, trolley system, to do essentially the gauging survey. So it's surveying the rails. It's using that control network as its basis. And it's got the scanner on it, so it's doing that gauging at the same time. And to push those running tunnels, the main sort of running lines, it only took about 3 weeks, I think, to collect all of that data. So there's a lot of prep stuff, but that collection of data didn't take too long. And then that's the basis for that project, for the initial sort of feasibility and things. It can provide visualization for any of the stakeholders as well. And, you know, obviously doing it with that system reduced overall sort of boots on the ground that we needed to use to do that survey. Certainly got there a lot quicker than we would have done with the ordinary, the stop and go way of doing it. And so in terms of this initial sort of gauging, so the assessment still done in Clearroute software, but in terms of the visualization of what are these problems that we've got out there, what are these infringements, we use this Judo software to do the visualization instead. So rather than, if we've done the assessment, I say we, it wasn't my team that went out on the ground, it would have taken, we estimated, about 14 weeks if we run the assessment and then gone, right, these are all the infringements all the way along these 22 kilometres. We're going to send out a team of engineers, go and look at each one of them, check what it is, take a photo, record it, put it into the report. So instead of doing that, we took the scan data, put it into this software, and went, okay, well, here are the infringements. Let's go through and find them. Handily, it's colouring quite a lot of them in red here, so you can see what it is, see what the magnitude is. Again, take these screenshots so it can be in the report, people can understand what they are. And then we still did validation on this data as well. So the ones that were maybe a little bit unsure exactly what they were, or the worst case infringements as well, just to make sure we got those magnitudes correct. Spent about a week out on site going and do that verification of the data. We've got a good correlation between what we found from the Judo software and then what was actually measured out on site. So it went from 14 weeks on site to 1, with a cost saving of about 40k on that bit of work. And also, obviously, minimising the opportunity for any safety incidents by keeping people off site. So that's that one. How am I doing? Okay. I'm talking too much. So construction, we can use these bits of kit for setting out. Very smiley surveyor there, which is good. So this is, again, was Camden slab track. We need to get this in the right place. We're going to concrete it in. It's not, we can't come along and tamp it again later. We've got to concrete it in, so we've got to get it in the right place. And this can give us the sort of real-time measurements of where we're putting this track, and we can do the fine adjustments, get it down so we're like 1 mil, 0 mil. Is it all good? Yes, right, concrete that in. We can also use things like the GPS again on for the 3D machine control. So again, this has been around for quite a while now, but because of those improvements and in the GNSS, we can get it to a higher accuracy than we used to, and use it in more places. So particularly the dual frequency means places that previously we were sort of too many high-rise buildings. Actually, we've got a much better chance of being able to use it and improve the quality of that installation, right from the formation ballast all the way up. It's got to get it right from the bottom, and the rest will follow. And we'll also put on there, tamping. So again, we can follow a tamper with this bit of kit and just check that we've got things in the right place. And then I put drones on there more from the point of view in a construction context, that you can use them to monitor the progress on site, particularly if you've got a big construction site. If you fly a drone over it once a week, for example, you can then feed that back. People can see, you know, project managers, stakeholders, everyone's got a view of the site. You can maybe do some calculations from like volumetric calculations if you've got your Alison or whatever, see how things are being used. And just before we get rid of away from the sort of track mounted, I thought I'd very quickly mention train mounted systems. So these are also good for long. So if you've got a long whole line survey, perhaps, then it can be good value, because this is, I mean, it's quite a bit of kit. It's quite a lot to get it on and to get it approved and all of these sorts of things. Generally, they'll do more than one pass along a section, and then sort of essentially average that data with using some clever algorithms to bring that accuracy down to within sort of 10 mil. That's kind of possible. So yeah, also use a GPS. So again, not in the tunnel. 3D laser scanning in general. So I talked about scanners a lot, but as well as putting it onto a trolley, we can put it onto a tripod and then let it spin all the way around. So 360 spinning around, collecting points. Again, millions of points in a second, and all the way around. So we can do lots of setups of these across a site, and then create this point cloud of data with millions of points in it. Again, with these, they've been around for a while, but incrementally they're getting better. So they're getting faster, lighter, stronger, possibly more colorized. So this one has got integral cameras built into it, and so you're getting scanned, but you're also doing photography at the same time. So when you bring those two bits of data together, it just makes it a lot better for visualization, a lot easier to move through and to understand and to sort of read and use. This is not what I mean by colorized, by the way. I do mean sort of photography kind of thing. It makes it look like you're on site rather than this would be a bad acid trip. I don't know. Benefits of some of this tech is you're capturing everything. So where we said, I mean, obviously at the start, it's good to have the right spec to say, yes, these are the things that we need. But if afterwards you go, if you go into a normal server with a total station, you'll collect the data that you were asked for. If someone comes back and says, actually, we needed the as well, well, you're going to have to go back out on site. If we've collected stuff with the scan data and we've got this point cloud, you've got a much better chance of being able to pull that data out of the scan data instead and not have to go back to collect it. Other things, so it might not just be sort of an area that you're scanning or a site or whatever. We scan some of the old Bakerloo line vehicles as well, just to check. Because when, back in the day, we got the design essentially for these, but the models again in the gauging software are built from that data. Quite old. We wanted to check: is it valid? Is it still, these vehicles have been maintained for 50 years, so is it still valid? And good news, yes, mostly yes. Very small tweaks, but yeah. So we could just validate, check: is the data we're using correct? So yeah. Next, so the processing and the CAD modeling. It's not just the advances in the data collection modes and methods that we've got. We've also got quite a lot of advances in the software that we use to process this data and also to share it. So there's more automation in some of these processes, which makes things quicker to do. There's opportunities for machine learning. So there's there's so many options with this, but it could be from using that data and saying, okay, we've got this scan data of the railway. Can we find where there are clips that are unclipped, or can we, anything like that? So we can feed all this data into potential for machine learning. Many opportunities. Again, with this processing, we've got the end user in mind. So whatever they need to be able to do something. So it may be they just want cross sections through something. If it's an embankment, they might just want the cross section. Giving someone a whole point cloud to work with is difficult to do. Very sort of big, slow to move. You need like lots of computing power for it. So we can process that data and give people just what it is that they need instead. We can always come back to the point cloud data if they want something else. Moving on to drones or UAVs. So unmanned aerial vehicles, unpersoned aerial vehicles, uncrewed. Someone said to me, so uncrewed aerial vehicles, probably better. So, again, there's a lot of these, very many varied user cases for this. We've got big, heavy drones, big beasts carrying lots of gear, but can do a survey that's good enough for track design, so getting down to sort of accuracy of kind of 5 mil. We can use them for monitoring, for inspection. So we can use little wee drones. I've got a picture a bit later on of like ones in a little cage. Do inspections with those. So again, it depends what it is that you want to do. Find spaces as well. So it's not just aerial drones, I suppose. I don't know if any of you have seen the little dog drones yet. Yeah. I couldn't have a picture, so I'm sorry. You can get mechanical dogs essentially with, again, a scanner head mounted onto it, and if you've got somewhere, I don't know, maybe contaminated or maybe under a vehicle that you don't want to send a person in, send the dog in. Give it a treat afterwards, maybe. I really want one of these dogs. Anyway, so drone survey. So this, believe it or not, it's not a photograph. This is a drone survey for Ruislip Depot that we had done, and this is the vast majority of it is good to 5 millimeters, so it can be used for track design. The majority of it probably is going to be used for feasibility at the moment, and then we can hone in on what it is that we actually need to do. Again, the sort of capture everything option. So we've got all of it, anything you can see from above. Slight problems where there were trains parked that didn't move in any of the there were a number of weeks doing different flights. Some trains didn't move at all, so no, we can't see through the train. We don't have the bit that's underneath, so we can make some inferences, but yeah. This is actually all done from photogrammetry, so it's flown multiple times from about 30 meters above the track. It's with a 100 megapixel camera. There is survey control that is on the ground. So think back to that original slide with the black and white targets. So those would be installed all across the depot. So reason for doing this survey with a drone was access, depot access, nightmare. We still needed access. This is one of our suppliers that did this survey for us. They still needed access to go and install the survey control, but they didn't have to actually get on track. They could go along the walkways and along the roads and install the control along there, which was better access. Lay out that network and then fly the drone up and down, I mean, a lot. I can't remember, should have written it down, how many photographs, but it's a lot, like a lot. It took much longer to process this data than it did to collect it. But we've got this 5 mil accuracy model of this depot and everything that's there. So as I say, access was the main thing on this. A few things to consider with drones, though, is things like the Civil Aviation Authority regulations. So these pilots do need to be highly trained. They need to keep up their license. There's also things like if you're flying near to any other like airport or anything like this. So there's quite a few, more than I thought, RAF bases in and around London. And then obviously you've got the big ones like, you know, Heathrow and things like this. So not impossible, but it takes, I guess it's a different thing. It takes time to do all of those parts of the process. So that just has to be factored in when you're thinking about using drones, particularly over, again, like over network rail or over LU. You know, again, we have standards, we have approvals. We have some drones that are approved for use on the network and some that are not. So, okay, yeah, and this is just a bit of an example of what we've then created from this. So we've got the point cloud, which is massive and quite unwieldy. It takes a while to sort of load up and use, but from that we have also got just the CAD like sort of line work extracted out of that can be used as well. It's a bit more sort of user friendly depending on what it is you're trying to do, and we've got all the photos, so you can zoom right in. Let's see what I've got on the next. Oh no, I haven't got it. Where is it? Okay, just So I guess the example on the far left of some of the photography is not actually from Rice, it's even older. But, you know, if you wanted to, you could zoom in there and count the ballast. You've got, you know, a high sort of degree of resolution. I don't recommend you do that. But moving away a little bit from actual rails, we can also do things like embankment surveys with drones. So might be a bit lower accuracy that we need for this. So we've got, again, options to just maybe use GPS on the drone or use less survey control out there. Use a different type of drone, perhaps. We can penetrate the gaps in the vegetation. So actually, just because something's covered in trees doesn't mean that it won't work doing this. It can work really well. It's actually better with tree cover than it is with very sort of dense kind of bushy foliage and things like that. Struggle a little bit more with that. But we are sort of trialing using this for sort of embankment monitoring. So we have quite a few embankments that, you know, heave and move with the seasons. So we can a bit, you know. So we can monitor those on a sort of year by year basis to see what's happening with them, this sort of technology. And again, you know, depending on the steepness of your embankment, they're not much fun to go out, boots on the ground, trying to do these surveys. You know, we do have injuries from that sort of thing. So if we can reduce boots on the ground, then that's all to the good. This one I was talking about, so inspection. Working at height, working at height, confined spaces, these are all sorts of things where you might not want to keep sending your people in. Potentially you can send a drone. So you might not be doing measurement necessarily, but you can certainly do a visual inspection. We've used these on bridges over the river. So obviously you can't go and sort of poke it and see what the integrity of the structure is like, but you can do the visual survey from here and make some recommendations based on that. Whereas I think that's Victoria that's flying above doing that sort of roof inspection, which obviously if you're going to do that with a person, again, you need all your scaffolding and blah blah blah. Just send a drone up. SLAM. So this is simultaneous location local. It's that. Okay. So essentially this is handheld or body worn bit of kit, and it's lower accuracy, so you're not going to do a track survey from this for sort of design or anything like that, but doing something like capturing a station or station grounds, it can work really well. So the sort of blue bit on the picture on there is the wiggly line that someone walks while they're wearing this. So it has a little sort of low grade scanner and on the top, and it also has cameras all the way around. And then it has very clever software in it, so it will essentially collect this data and then stitch these images and this point cloud together, and stitch it all together and create you this sort of virtual tour to walk around in. You can actually, so it's quick. That's the main sort of benefit of it. You haven't got to install lots of control out there. If you do install survey control, you can actually add that in, and then you can put it onto whichever grid it is that you want to work on. But if you just want it floating in space, as it were, you can just collect it and just use it for that. Great again for like if you've got somewhere you don't want lots of people to have to go and access. Or again, if it's something where it's maybe there's just access at night for a couple of hours and you don't want to sort of, you've got a whole project team and you don't want to have to get them all out there at night. If you do this, then they can do that sort of virtual walkthrough, virtual site tour instead. Very useful for that. And you can take some measurements from it as well. It does struggle in some environments. So for example, tunnels. Because it's using pictures and it's going, oh, I've got this surface in here or this plant in here and I've got it from here as well. I can stitch it together based on this sort of common things that are in its photography. Where you've got something like a tunnel that's very, very repetitive, it gets very confused. So not ideal for that. And then in a similar vein, this is really more just about the imagery and the photography. So we've got a Matterport on the left, and there's this other what is it, DJI camera. So they're very small and light, particularly the one that's just a camera, very, very small and light. You can just put it on a photography kind of tripod. You then just taking 360 images basically all through a site. So this is Farringdon. With the Matterport, because it's got a sort of a very, very low grade like LiDAR or scanner in it, you can take rough measurements. I'm not sure on this because it will give you a measurement, but you have to understand that it's not necessarily an accurate measurement. So sometimes that's worse. If you understand that it's just ballpark measurement, then that's good. It can be useful, but don't make any safety critical decisions based on that data. But fantastic for doing this sort of your planning, your stakeholder engagement, and all this sort of thing, and fast to do. What else? So a bit on reuse of data. So harking back again to the scanning data for our gauging and clearance, we thought, what else can we use this data for? And actually, tunnel inspection is something that we are working on at the moment. So we can collect that photography or video at the same time as we push that trolley through. Assuming that we put enough lighting rig on it, we can take those images, and once we're doing those repeated surveys, they can be overlain in, again, various softwares to see, like, if we can identify cracks, how they might be changing over time, things like that. We can also use that scan data itself within some of these softwares, either for things like circularity or deformation, but also even for cracks, because we've got it at a very high resolution now, and the scanners again are getting higher and higher resolution. We can use that data for this sort of thing as well. So we've got it for gauging, but we can actually reuse it for this tunnel inspection as well, and monitoring those changes over time. So that's handy. But how are we going to access it? So, as I've said, a lot of this data is massive. And how can we collaborate between sort of these different stakeholders or different contractors, between contractors and clients? So we have common data environments to work within, which in theory give us this single source of truth. We've got sort of various options with this, I would say. That I guess the thing is that there's not one perfect solution to this. There's now quite a lot of sort of cloud-based platforms, which is great, because it means you don't need your big computer. You don't need sort of a very high-end computer to be able to access some of this stuff, because it's all being held separately on the server, and you're just sort of accessing into it from your laptop. So we have things like Reality Cloud Studio, which is great for point clouds, hosting those. You can take your measurements within there. You can have lots of different collaborators that can access that data. You can upload lots of different types of measurement from there into there as well. People like One Big Circle are more video based, but you also have, as well as sort of just their normal cameras, if you like, you have like thermal imaging as well that they have. So again, can be good for for monitoring. Cordell again do like LiDAR and gauging, things like so as well as the sort of gauging, it might be things like vegetation along a route. So it could be used for doing sort of your maybe leaf fall modeling and things like that, so that you can base your sort of interventions on that. And they're very much bringing sort of AI into how they use that data and how they interrogate that data. And that's just a couple that I've sort of picked off the shelf. There's lots out there. So I guess the thing is thinking about what it is that you're trying to do, who are the people that you want to collaborate with. And then I put this bit in here about this sort of data classification. The benefit of these platforms is lots of people can access this data, and they don't have to go and ask a specific person for it and get given it. Downside is that you need to know where this data came from, what's the accuracy it was collected to, what was its purpose. If in one place you can access point clouds that were done with these on control networks, on these scanners, and are good to a few mil, but you can also access something that was done with this Matterport that is good to 40, 50 mil, you need to know which bits came from where and what you can use for what. So that's the potential pitfalls. These are the bits that I like to flag up. And then, yeah, just things like sort of access, security of your data, management of your data. These are the sorts of things that I want to think about. Skipping quickly on. The digital twins. So very quickly. Theory of a digital twin is a realistic digital representation of assets, processes, or systems in the built or natural environment. The benefits of them: to enable better decision making throughout the whole life cycle of an asset or system. Key points for this is it needs to have a data flow between the real and the virtual space. So you can't just build it and say, oh yeah, we've got the digital twin. You need things feeding back into it, data feeding back in. It needs to be maintained and updated, and you need to maintain the synchronicity between the two. And so that's the thing with this, I would say, is that you can collect all this data. You need someone to manage this data. So yes, so this is coming on to the very end. So we've got all these advances and they're great, and we can reuse some of this data for lots of different things, which again is great. It's maximizing the value from it. But it is big, it needs big servers. And things, big data and big servers have a carbon cost to them. And they have a management cost to them and a sort of management maintenance of this data. So that is my sort of closing point, I would say, is there are lots of options out there. Beware of anyone who says they can give you a very high accuracy survey with no need to access anything or put any survey control out there, because they're probably lying. So the bottom line is ask a surveyor if you're not sure, and do think about what it is that you're collecting, how you're going to use it, and how you're going to maintain it and carry it on for the future, and who's going to take sort of responsibility for that, and do they have a budget? Yes, so conscious collection is my very end point. Okay. Any questions? I'm going to try and breathe. Yeah, well, 3 minutes of questions, Dominic. I timed that well.
It's really, really good. I was wondering that with the increased accuracy of both surveying and you even scan the train as well, is there a thought to change the standards in terms of the gauges that you design?
Like how much sort of fat you're building in?
Yeah, because they're quite old, aren't they? And they're sort of
very good point.
a big wooden thing holding it.
Yes. Yeah. Just one picture of them, yeah. Yeah, that's an excellent question. Yeah, I mean, potentially that is something that could be revisited.
Yeah.
I don't know if that is where you would find the biggest gain.
Yeah.
Because I know there's lots of other factors that are sort of fed into some of that like analysis of things.
Yeah.
So whether that is where you would find the biggest gain, but it's certainly worth thinking about, because yeah, we can get it to a much higher accuracy. Yeah.
That's interesting.
Hello, Mike.
You mentioned the 3D laser surveying, and if I understood correctly, and I didn't necessarily understand correctly, you said that some systems take photographs.
Yes.
At the same time.
Yes.
So, given that these systems take gazillions of points, are they taking gazillions of photographs as well?
No, not gazillions of photographs.
Right.
I don't know how many photographs.
No. But there must be some relationship between what the system scans.
Yes.
And
then how it's
where it decides to take a photograph.
Yes. I mean, it is in the same bit of kit, box, as it were. Yeah. So it knows its relationship between its camera or cameras and the scanner head, if you like. Did I mention we have advanced software that has all sorts of clever algorithms? I don't know how it does it, Mike, but it does it. Yeah.
I just thought there was,
But it's not like, you're not sort of taking as many photos.
Data for scans.
Yeah.
Oh crumbs! If you're putting photographs on that as well, that must be,
Yeah. Not as many photographs as it is scanned, thankfully. Yeah.
One part you didn't really touch on is the people element. going back a few years now, I worked heavily on the Crossrail project when we started up, when we started all the surveys of all the track. And I remember we built up this huge survey model. We put all our designs, we built all our designs in it for all the changes we do. And we got to the end of construction, and we're handing this Crossrail project back through all that Reading things, and went to maintain it. And I've got this fantastic 3D model. We've literally drawn every piece of rail, every piece of point work, all the overhead line we've just put up. It's all there in the 3D.
Yeah.
What do we do with it now? All that, all money, all resources, all oh dear. We're just like, you can't throw this in the bin. Seriously, and they did.
I feel your pain. Yeah. I mean, it's definitely take your point. It is
getting people's buy-in just to mentally accept it's really useful
to maintenance and going, how can this data be used and reused? I guess from the sort of surveying side of it, I'd say that things like the sort of infrastructure around it, so like that survey control needs to, as long as you sort of maintain that, you can come back and re-put. I mean, you probably need to upskill your maintainer. And really upskill your maintainer. It's the sort of getting them on board part of it. It's the sort of proving that it's like this is worth doing. That's probably the biggest.
Just seen as another
challenge,
another budget constraint, another thing they need to spend money on. I can't afford that. Sorry.
Yeah. I think it's a very good point. Again,
sorry, but just to directly follow on from what you said and what Phil just said. Data is an asset.
Yes.
And like any asset, it needs to be maintained.
Yeah.
Like a piece of track or a bridge or a tunnel. It's got to be maintained.
Yeah.
So
the mindset shift.
It's all very well to collect it, but yes, you've got to maintain it.
Yeah.
Because I know certain companies, I won't name any, who've gone around collecting lots of data about their asset. And it's just festered and gone rotten and gone off and gone well past its sell-by date.
Yeah. And it's probably still being stored
somewhere. So data is an asset. It needs to be maintained.
Right. As a rule of thumb, what's the relationship between the amount of data, the area you survey relative to the amount of data you have to process afterwards? So go back to Ruislip.
Yeah.
You probably surveyed about 20 clicks a track. 20 kilometers a track, do you think?
I wrote this down.
How many data points?
You saw him coming, didn't you?
and storage rate that comes behind us.
It's a pre-prepared question.
I wrote it down. 500 gigabytes of Ruislip data.
500 gigabytes.
500 gigabytes.
That's enough to get to the moon and back.
That gives my pal a headache,
So and it did take blooming ages to process. I mean, we didn't process, thank God. But so big.
As you say, it's very good way of doing it. I completely support doing it, but the data thing, I think it must be quite a challenge.
Yeah.
But do you
They
think?
go back, sorry, Dominic. They go back to Mike's point about data and data being treated properly.
Yes.
I think businesses still struggle, including one of the businesses we're more involved with, software licenses and digital data.
Yes.
And the concept of having a digital asset engineer or a digital department is lost in them to manage those two things, the data and all the software licenses that go with it.
It's definitely a challenge.
Yeah.
There was another hand up somewhere. I don't. Hi, sorry.
I saw that you've been out on Croydon Tram. When have you done any street surveys, and how do you interface with the council for the highway?
So we do street surveys, or we as a team do them, but I don't do them. I don't get involved with them, so I actually don't know.
Okay, it's just an obvious question, seeing that you straightforward when you're on the segregated section.
Yes.
But obviously, the street running section has a lot more interesting interfaces with other parties.
Yeah, absolutely.
And needing to have the two models that match, assuming Croydon's got a model.
Yes, I mean, so there is a survey control network that goes all the way through Croydon Tram, so be that on the sort of road sections and the Alison sections as well. So there's a control network that does tie it all together. But in terms of sort of getting the access to do the surveys based on those, or on the road, I'm not quite sure who goes, or who we in fact go to sort of get that organised and things. But there should be one control network that holds it all together. Yeah.
Questions online?
Okay.
Thank you for a great presentation. I've got quick questions because there was a lot of talks about the survey around the DLR. Is it still gonna go ahead for the track survey system-wide?
I don't know. There you go. There's a short answer. Yeah, I'm sorry. I don't know whether it is or not. I know we're doing surveys on the DLR network, but they're very much sort of project by project, sort of based on sort of the S&C and stuff like that. So, or particular S&C. But yeah, in terms of doing again, there was a survey on the DLR. There was again, like network-wide control network and things. Like 15 years ago, there was a whole, but whether that's going to be repeated or, I guess the question is who's got the money.
In other words, it wasn't kept up.
Potentially not, no.
From online, is there a bathymetric measurement feature for drone surveys as well?
I'm sure there probably is. Not my forte. There might be someone in the audience that could answer that. Sorry, apologies. I could get back to you on that, but I can't answer it now.
And when are we going to be able to use total stations for setting out track-on projects and maintenance, where we can have design loaded in the total station and just set the track back to design rather than eyeing it?
I mean, probably depends where you are. So, I mean, if the control network is still there, that your design is based on, then in theory you can go out there with a total station and set the track back to that design position. But it depends on the control network still being there and whoever it is that's controlling the budget, giving you a budget for a total station. But yeah, definitely possible. Yeah. Roger.
Hi, Alec. Great presentation, and thank you for that. Just a question and a consideration. I don't know how that sits with you. With so much data that's been taken and captured, protection of that data, and ensure that longevity speaking. I know that we say that we don't want to get rid of it, but in as much as you have to keep it, poses you a risk future-proofing of where that information is stored, how that's stored.
Yeah.
Is that a factor for you and your team?
It is. I mean, it's certainly we've had sort of discussions about as to where. I mean, there's a risk both ways, I suppose, in terms of the risk to sort of give it out to kind of the commercial world and sort of these big data centers or wherever they may sit. In terms of sort of maybe more of a security risk from that point of view, but probably means it's quite safe in terms of it will still be there when you want it. If one server goes down, there's backups. We have previously in another life had sort of like standalone servers in our buildings that have got the data on it there, so they're not connected to the internet or anything like that, so no one can get at it. So from a security point of view, great. But if something happens to that building or that room or whatever, then we've lost all of it. So yeah, so considerations on both sides, and I guess they have to be balanced. And the point of view, like from who's again like maintaining it and things like that. If you're trying to maintain a lot of that within like a sort of small team to keep it offline, more difficult to do and potentially very costly and things like that. So yeah, but yeah, and then also I guess from the maintenance point of view of it, some of this data we don't need to keep, some of it we do, but if something's been collected and then it's a whole layout was changed and actually you've got your sort of new like as-built data, then do we the data we collected 10 years ago and the old layout, do we need that? No, probably not. But again, you need to factor that in of doing those reviews and going, this is not needed anymore, get rid of it. Whereas, because that takes obvious time and money of someone's time to do it, it doesn't get done. So instead, the cost is in the sort of paying for the storage and the carbon cost of keeping that data in the background. So yeah, there's cost either way. It's just one of them's more hidden than the other.
Sure.
Okay. Sorry, did you have a question? No? Okay. No worries. Okay. Well, Alison, thanks very much for the presentation. I think it was an excellent presentation. Like most surveyors, you had your own journey into the room. Yeah. It's probably something you didn't set out to do, as you said yourself. Most of us don't. We just end up doing it. And from there, end up going into track. And, I don't know. After that, just keep plugging away at it. It gave us quite a lot of enlightenment in how technology has changed and adapted and how you can use it to overcome challenges with access, costs, a lot of conversations and questions about management of data, how we keep data up to date. Difficulty in all essence is trying to manage change as well. Something changes on site, has it come back into the model? If it's not come back into the model loses credibility, and someone goes, start again. Yeah, that's the reality of it, but I think that comes down, there's quite a lot of debates at the moment about AI and liability, and it's actually been brought to surveyors' notice by the RICS in the last couple of months about management of AI and where does the risk sit. So as well as cost, there's risk. But technology, the trade solution, very good. Dominic can answer your question. I think you could take one trade and measure it, but then you have all the scenarios around changes with trains, and does that invalidate the model for the train? Just a little story going back to when I started in LU. Griffin and I train had a fight with Tower of Piccadilly Circus. And one of the jobs I had was to go out and measure the train with Bill Myers after it was repaired. So I'm glad it went back in, that it was in like the gauging model is still relevant for the Piccadilly line trains. But very entertaining conversation. I think it brought us forward a long way in what's going on in the survey world, and in time-honored tradition, round of applause for Alison.
Yeah, thank you.
Just a reminder, our next meeting is on Thursday, the 12th of March. And if anyone wants to join us for drinks or refreshments afterwards, Mike Fowler will probably lead you all to a
Great.
Thank you.
Thank you. There's still some biscuits left on the back spikes.